Okay, what we're going to do in this video is take a look at an equation. It's still a linear equation, just has an x in it, but they're all over the place. You got some on the left and some on the right. We're going to look at how to attack this problem in a way that makes it look a lot simpler than it does right now. And to start off with this, it's best to not look at the entire equation at all. Okay, let's just look at one piece of it. Let's take this stuff right here. I know we've got an equal sign right there, but let's just pretend we're looking at the left side for right now. Now, when you see parentheses, most people kind of get this habit going that they just automatically distribute. And while that's not always the case, it's a good idea. If you can make the parentheses go away, let's try it. So let's rewrite this as 3x plus 6. Okay, still has the same meaning. We haven't changed anything yet. All we've done is just adjust the way it looks. Now, remember we have this equal sign here. Let's look over at the other side and just pretend that that 3x plus 6 isn't there for right now. Now the other side has more stuff in it, okay? But there is definitely a part right here. Looks a lot like what we just did on the left side. So let's rewrite that. That would be negative 4x plus 20. And keep in mind, when you distribute a negative to a negative and multiply those together, you're going to get a positive. Now that one little weird thing is this right here we haven't done anything with. That's still there. It's a positive 7. Now already our equation is starting to look a lot better. And the one thing that generally bothers people the most is that you've got this thing right here and this thing right here written separately. But if you recognize, those are what we call like terms. Okay? And they're like terms because neither one of them has an x. So they go together nicely. So what I'm going to do is just add them together and make one term out of them. So let's call that 27. 20 plus 7 gives me 27. And you can do that anytime you want. If you find two terms that go together nicely and they're on the same side of the equal sign, just add them together into one. Now we still have negative 4x, and I'm going to put a plus here because that's what we have is a positive 27. We have an equal sign, and on the other side we have a 3x plus 6. Okay, now this equation still has not been solved, but it looks a lot better than what we started with over here. A lot less stuff to worry about. Okay, now when we get to this point, we're trying to figure out that unknown number, that variable. So we need to get all the terms that have an x onto one side and all the terms that are just numbers on the other side. But it doesn't matter which is which. What I'm probably going to do is I'm going to choose to add 4x to both sides. Now, I didn't have to do that, but this allows me to work with positive numbers that are attached to my variable. Not that it really matters, but it's just easier for me. So that gives me 7x, and I still have plus 6. That hasn't went away. I still have equals, and now on the other side, the only thing that's left is 27. Okay, so if my x terms went to the left, I'm going to move my other numbers back to the right. So I'm going to subtract 6. And by now this should look like something that you recognize. It's kind of it's something that you just do kind of as a habit at this point. So my equation now becomes 7x equals 21. Divide by 7. And that gives me a value of x equals 3. Okay. I hope this helps with big equations. The main goal is to take something that looks complicated, like this right here, and if you can use the distributive property, or combining like terms, or just rearranging things, moving them around across the equal sign to get it to look something like this, well then, once you're here, these two-step equations have almost become just a habit you do without much thought at all.